Good morning. Good morning. Good morning. Good morning. Good morning. Happy Monday. Trying to pin something. Good morning. It's not letting me pin this morning. Good morning. There we go. Good morning. Happy Monday. Happy fourth quarter. You made it. It's the last quarter of sixth grade for many of you. So we have new material to go over if you've been going through your packets. We're in the distance learning packet week 4 and 5, it says, right? And ours is week 4, day 3 today. So we did day 1 and 2 last week. I'm reminded you to keep your packets. So if you turn in work, anything from before now, you can turn in for third quarter work. The work in this packet will count towards fourth quarter. And also, I've been posting grades as people are doing iReady and Khan Academy and DMing me your work. I'm giving you grades for participation in your Instagram lives. So there have been lots of ways people have been earning points. When you DM me work, though, you have to show the work. Don't just DM me the answers, because a lot of times I already gave you the answers. Silly. You've got to show me the work. So the work is what you did with the operations, the adding, subtracting, multiplying, and dividing that you did within each problem to solve the problem. Even if it's something I went over, you need to show that on your papers. So today's due now. We're still early. It's before 10. Today's due now was a warm-up for you to do on your own, and I had put that in the announcement I made last week on Instagram about what you had to do for today, and I said to go ahead and that you could do this on your own. It was an addition and subtraction sprint with little equations. Okay, so that was your do now. If you did not do it before class, I recommend you do it after. Again, it wasn't just for you to copy answers from the answer key, because they gave you the answer key. Good morning, good morning. So the point of it isn't just to copy the answer key. You know, I know you can do that. I know you can do what number plus 4 is 11. The point of it was to see how quickly you can do a lot of these now. Because as we've been practicing adding, subtracting, multiplying, and dividing all year, you're actually getting faster and faster, even though you may not feel like it or may not know it. So that was the point of it, was to set a timer for 60 seconds, see how many you could get done, and then even when the timer went off for 60 seconds, then draw a line there and just, you could check those answers and see how many of them you got right, and then just finish the rest without a timer. Okay? So, they wanted to see if you could figure out a pattern while you were doing the do now. Good morning, those of you just logging on. They wanted to see if you could see some kind of a strategy that you could develop to solve these. So, if you're just logging on, I'm just telling everybody, I'm talking about the do now and how the do now was just to be a warm-up for yourself, set a timer for 60 seconds, and then solve for M. They're all addition and subtraction equations, and they wanted to see if you could come up with a strategy. So one of the strategies potentially is when you saw that something was an addition problem, that to make it faster, you understood that that meant you had to subtract the number, the other addend from the answer, from the sum. So you could take 11 minus 4 and you'd get 7. You could take 5 minus 2 and get 3. So they wanted to see is as you did it, if you realized that you were actually, developing a strategy. This is tricky when you do the ones like this really fast, because then people think, oh, 10 minus 7 is 3. Well, that would mean that 3 minus 7 is 10. And we know that's not true, right? So in a case where you're subtracting, because this is different than the first 3 that we're adding, and again, that's something else they were probably checking, you actually have to add these together, okay? So you're doing inverse operations on a lot of these, right? So 10 plus 7 would have given you 17, and to check your work, 17 minus 7 is 10. So, the strategies would be the inverse operations, using the inverse operation to find the missing variable. Okay, so that's what the intention was of the warm-up. It was to see how many you could do in 60 seconds and then to do the rest. And a lot of them you can't necessarily do in your head. You would want to check maybe your work. And so that's why there was no time limit, on finishing. But these exercises, they help you warm up. They help you get better and better at math. And they're really not that hard. These are exercises. You could do this with your whole family like a game. If you had written out these problems, you could write them out for everybody, even younger brothers and sisters, in your parents, and just see who gets the fastest. And then maybe you could teach them some of those strategies we just talked about. And then they get harder and harder as you go on. So they even start using decimals, and you could show your family how to line up the decimals to add and subtract and use those inverse operations. And so that was the final question when you're done for the do now, is what's a strategy you noticed to make solving the problems more efficient? Okay. And they're just reminding you the word efficient means faster, solving them faster and better. Okay. And then they gave you the answer key. So again, that's why we wanted you to look at it yourself, and you can check your answers on your own time. If you don't have this packet and you didn't pick it up at school, remember you can download it from Teams, okay? Or you can DM me and I can email it to you. There's lots of ways to get it, so there's no excuse now for fourth quarter not to have all of our work. We've got some new people joining that haven't been participating, and it's great to see everybody. So if I didn't wave at you, it's not that I don't want to. It's just a lot of people coming on at once. So hi there. Thank you for joining. If you know other people are not here, you want to, send them a quick reminder. So today is new learning. Let me see if I can show it on my screen. Today is some new learning, but we're going to review a skill that we've actually been doing, and that's what we're going to apply to our new learning. So we're all familiar with the coordinate plane, right? We've been using that this year. We realized this year that instead of just using positive numbers on the x-axis and positive values on the y-axis, and therefore only using quadrant 1, we expanded into using negative numbers, and what we called those numbers integers. And so when we had positive and negative numbers, we could go left and right of the origin on our coordinate plane, and we could go up and down on the y-axis of the coordinate plane. And so that led us into these other quadrants that we hadn't used really before this year. So in 5th grade and earlier grades, we always concentrated on the numbers that were positive. So they trained you in quadrant 1. And then we learned this year, again, this is review. Good morning. We also learned this year that the quadrants had numbers, okay? That should have been a review, but we talked about how the numbering goes counterclockwise, and counterclockwise we talked about is the opposite way that a clock goes. A clock, the hands on a clock rotate to the right, and the quadrants get counted to the left. Okay, and we said if you take a pencil or pen in quadrant 1 and you drew the letter C, that is the direction that you would go on a coordinate plane. Okay, and C was for coordinate plane. So good morning. So quadrant 1 is here. If I kept going with my C, then I would be in quadrant 2, then I'd be in quadrant 3, and then I'd be back to quadrant 4. Okay? So, like we just mentioned a few minutes ago, quadrant 1 is where your X and Y axis, your X and Y values, are both positive. So that's what the positive means, right? When we draw our coordinates, the points, the coordinate points, okay? Where we have the coordinate pair. It's a positive number and a positive number. Quadrant 2 then is where you start at the origin and you would go left into the negative numbers, and then you would still have to go up, which is positive. That's how you would get to quadrant 2. So that's a negative number and then a positive number for your X and Y. If you start at the origin and traveled into the negative numbers on the x-axis and then more negative numbers, that would show you that you're in quadrant 3. And that's if you have a negative value and a negative value as your coordinate pair. And then if you started at the origin again, which is 0, 0, if the first number is positive but the second number is negative, that would actually take you then down into quadrant 4. Okay? So that's the review of the quadrants. And that would be something great that you could show some of your younger siblings and family members. So now we're going to look at these. They wanted you to plot these points. So in the comments, you're just going to tell me, and we're going to just use the regular numbers, 1, 2, 3, and 4. You don't need to use Roman numerals. But why don't you go ahead and if we had the number -2, +3, okay, which quadrant would that be in on this coordinate plane? So just go ahead and type that in. The page we are on in the whole packet is page number 3 of day 3. So it started with this page. If you're tuning in late, it said day 3, solving problems with polygons on the coordinate plane. Okay? And so the do now we already talked about, and we're on the part with new learning. So go ahead. Good morning. I'm waiting for people to type in what quadrant the point -2, +3 would be in. So you have a negative number and then a positive number. Good. Good morning. Good morning. And you can just write your number in your space. What quadrant? You don't have to use the Roman numerals. Just type in the comments what quadrant. Somebody got it right. What quadrant is the point -2, +3 in? -2, +3. Okay, you have this all in your packet, but you can look at here. Good. Good job. Good morning. Good job. Yeah, -2, you would start at the origin, you'd go over 2, and you would go up 3. So you'd end up in quadrant 2, where the first part of your pair is negative and then positive. Great job. So, number 4. I can't do teams now because I have to set that up ahead of time, but I can do that for somebody's asking if I can go live on Teams also. We have to set that up ahead of time, so it's not something I can do instantaneously, but I can do that I'll try to do that then for Wednesday. Okay, so I hope that's okay, but that's what I'll do. Okay, so the number 4 and -2. 4 and -2. What quadrant are we in? A couple people typed it in. 4 and -2. Start at the origin. You would go over to the right 4 because it's positive. And then -2, you would go down for your Y value. And you'd be in... Sorry, it keeps pausing. Good. Okay, third one. The number 5, 4. 5, 4. What quadrant would you be in? Go ahead and type it in. 5, 4. We're still on the same page. This is page 3 of day 3 of week 4. It looks like this at the top. It says new learning. We're doing the quick review. It's right in the middle of the page. They have this coordinate plane. Okay, we're on this part. Good, 5 and 4 is 1. That's the quadrant you're used to working in, where everything's positive. Okay, quadrant 1. So when you have two positive numbers. Great. And then last but not least, -3, -3. What quadrant would that be in? You start at the origin. You think about, for a -3, which direction you're going on the x-axis, and then for your second value, where you're going on the y-axis. I see some 3s, I see a 4. Okay, if both numbers are negative, we're going to start at the origin, 0, 0. We're going to go left for -3, 1, 2, 3. And again, I'm just counting spaces. They have different numbers here. I'm just using the little units as my numbers. So if I went 3, and then I went down 3, which quadrant am I in? Good. Yeah, we're in quadrant 3. For two negative numbers, it's quadrant 3. It's actually the opposite. It's 180 degrees opposite of the positive numbers. Okay? These are opposites. These are opposites. We've talked about that a little bit too. Good morning, good morning. Okay? So, the reason we need to know that is because sometimes they give us these coordinates and we're forming shapes with them on the coordinate plane. So, below, they have one that they provided to you. Okay, this is one you were supposed to read this section ahead of time. They gave you 3 points. Okay, I don't see any negative signs there, and then they graphed them. So they started at 0, 0, and they did 3, 2, which is point A. Point B, they went to 3 and then up 7. And then point C, they went over to 8 and up 2. Okay? So, the question is then, good morning, how would you find the area of this triangle? And they wanted you to try it on your own before you flipped the page and read the rest. So, hopefully you did that, because this was the pre-reading you were supposed to do. And did anybody want to jump on and tell me live how you found the area of this triangle? They gave you the 3 vertices. Remember, the vertex is where the 2 lines of a triangle come together and form an angle. So this is that point. That's one vertex, 2, 3, and we said that vertices are the plural of that. Live. Remember, make sure when you come on live, don't show your face. Okay, so let's see, it's working. Good morning. It says they're still connecting. Honey, can you hear me? Hello? I don't know, maybe they're frozen. Can you try it again? It wasn't letting you on. If you want to try again, go ahead, honey. I don't know why it looks like it froze you and then it wasn't coming on. But if you want to jump on, we could talk about how you found the area of this triangle. Honey, do you want to try again? Here we go. Let's try it again. Good morning. It says it's waiting. Good morning.
Hey.
Hi, honey. How are you? There at work that time.
Yep.
How are you doing?
Good.
Good. Miss you. So do you want to talk about how you found the area of this triangle?
Where you can do height, parentheses, space 1 plus base 2 divided by 2, or you can count them.
Okay. I think you were right about the height and the base, except we're not doing a trapezoid, so you don't need base 1 and base 2. But if you took the height, you can take the height times the base, or the base, we always say base times height first, and then divide it by 2. So that was right. Or you could count them. So one of the issues here, though, was some of these aren't whole units. So what did you get as your answer for the area for that triangle?
I got
Did you have a final answer for that one?
17.
Okay, you got 17. So let me see. So we have a base. What did you use as your base? Because I would see 1, 2, 3, 4, 5 units.
Mm-hmm.
And then my height, 1, 2, 3, 4, 5 units. So
Can you repeat that again?
yeah, so you had told me the formula we were using was this.
Yep.
And so if I had 5 as my base, and I just counted
Yep.
5 as my height and divided by 2, if you multiply 5 times 5, what do you get?
10. I meant 15.
When you multiply them, 5
I
times
meant
5.
25.
25, right. Good. And then we have 25 divided by 2. So we actually have to do a little bit of a mini long division.
Yep.
How many times does 2 go into 5?
How many times? 2.
2. So 2 times 2 is 4. What's 5 minus 4?
5 minus 4 is 1.
Okay, great. And so that's our remainder. So we put that on the top of our fraction, and our divisor goes in the bottom. So you should have gotten an area of 12.5 units. Okay? All right, thanks for helping, honey. You can jump off now, but thank you for helping.
You're welcome.
Okay, good to hear you. So that's one of the ways we could have done it with the formula that we learned last week.
Yeah.
Okay. Oh, you can jump off, honey.
Oh, okay.
Let's see.
Press leave?
Yes. Oh, okay. And then the other way he was saying was you could just count the squares. So if I counted the squares, 1, 2, 3, 4, well, that's a half. I can't really count that. 5, 6, 7, 8, 9, 10. I have 10 that I can see the whole squares. And then I have all these little pieces that, because they cut through diagonally, are actually halves. So if I have 10 whole ones, and then I have 1 half and another half, so that's another 1. And I have this half and another half, and that equals 2 more. And then I have a half. Then that's where I get my 10 plus 2 plus a half, and I still get 12.5. Okay, but those are 2 different ways you can do it. They wanted to see if you remembered how to do it like he did with the formula. So at first he mentioned base 1 and base 2, and that's one of the trapezoid formulas. So the area of a right triangle, we want to remember. We want to remember the formula where the area of the triangle is 1/2 times the base times the height, which we said last week is the same as taking the base and the height and dividing it by 2. Okay, so that's what they wanted you to check there. And then it was asking you, how did you determine the length of the base and the height? Okay, and so one of the things they're talking about, besides just counting the units, okay, is that you can subtract the values of the coordinates. And we talked about this year when we talked about the coordinate plane in our other units. So for example, for side AB, which they said is the height, they subtracted the absolute values of the 2 y coordinates, 7 minus 2, and they got 5. Okay, so let's go back so I can show you what that looked like. So they took these 2 values, the y values, for point B, because it was higher, it's a greater value, right? They both went to 3. but then point B went up 7, and point A only went up 2 on the Y. So they took the 7 minus 2, and they got left with this 5. That's how they got that distance. Okay? So that's what this means when they're saying you can subtract the absolute values of the Y coordinates. Remember, your absolute value is always a positive number. And for those of you that may have forgotten what absolute value is, remember that's your distance from 0 on a number line. Okay? So they did the same thing for the length of AC. Okay? It said they subtracted the absolute value of the X coordinates, 8 and 3. So they just took the difference of those. Okay? Again, for point A, they went over to 3 and up 2. And C, they went all the way to 8 and up 2. So they had the same Y, so they subtracted the 8 minus the 3, right? They would take this value, 8, and subtract out this little piece, 3, and then you're left with 5, which is the distance between A and C. Okay? So that's where those numbers are coming from, if that sounds confusing. But it's actually, once you understand the coordinate plane better, it's a faster way to do it when we talked about how you'll be able to do it without drawing the parts. Okay? So then we're getting a little more complicated. So it's kind of exciting because it's fun, but there's a lot of detail here. So this part has a triangle that is not on, it says it's not on a horizontal or vertical line. Okay? So it's like they randomly drew it. And what they mean is that the sides of it don't line up with the lines that are already in your coordinate plane. Like this triangle they drew, this already lines up with a straight line, and this already lines up with a straight line on the grid. This line does not. So now they're showing us one where none of the lines do. Okay? And they're going to teach us the new method on how to figure out the area of it. Okay? So okay, can everybody see? Okay, so on your paper, and I'm going to read it just to save some time. It says plot the points for each shape and then determine the area of the polygon, and then write an expression that could be used to determine the area of the figure. Explain how each part of the expression corresponds to the situation. So that sounds really confusing and really difficult. Like it sounds like they're doing a lot and there's a lot of parts, but if you do it step by step, it's not that hard. So the first thing is that we're looking at the points, right? Points are written as XY, they're reminding you. The first number tells you how far to move left or right from the origin, and the second number tells you how far to move up or down from the origin, right? So these were the 3 points, -3, 4, +1, -4, and +4, +2, okay? So they took those points, they started at the origin for A, they went over 3 and up 4 and got A. For B, they started at the origin, they went over 1, +1, and they went down 4 units, and they got this part. And then for C, they started at the origin, and they counted over to 4 units, and then went up 2, okay? So this is the shape you get when you connect those points, A, B, C, okay? And it asks what shape it is. The shape formed is a triangle. So because none of these lines, though, line up with the grid lines, right, that go horizontally or vertically, these are all kind of diagonal pieces. There's a cool way that you can figure out the area of this by using a different method, okay? And so this is what they're going to start with. So I'm going to talk you through this one, and then we're going to go through one on our own. So it says, I'm unable to determine the base and the height by counting. That's right, because you can't just count, oh, well, it goes, you know, it looks like it goes this many units, so I'm going to count. Okay, that's not the way to solve it. So what they're showing us is where the vertices, okay, where the vertices meet a place on one of the horizontal or vertical lines, you can make a shape around the triangle that's easier to figure out the area of, which in this case is a rectangle. Okay, so we all know for rectangles, it's really easy. We talked about it again last week, we reviewed, to find the base times the height. Okay, or as we called it, the length times the width, right? So if we draw one and the lines of this rectangle have to be in line with the three vertices of the triangle, okay? So notice it doesn't go around it bigger and it doesn't go around it smaller. It has to be exactly in line with each vertex of the triangle, okay? So each one of them has to touch the line exactly, and then you connect that, and that's your rectangle. So then once we have that, what we're going to do is, because that gives us three other triangles, see, this is one that's blue, this is the other one that's blue, and this one that's blue. It's giving us three other triangles, and we can use them to figure out the area of those blue shaded parts, because they now have bases and heights that do line up with the horizontal and vertical lines that we can count the units of. Okay, and so it's going to make it easier. You don't see, what don't you see? Oh, is somebody asking about Teams? Yeah, I didn't have it in Teams today. Somebody asked if I could do it in Teams, but I can't just jump on and do it because we have to schedule that ahead of time. So I will try to schedule the one for Wednesday like that. Okay, so in order to figure this out, we had our triangle that we plotted. Then we would draw the rectangle around it. The outside of the rectangle has to touch each vertex of the triangle. And then we're going to pick the different triangles and number them and find the area of them. So we're going to start with number one. Okay. Triangle number one is. Okay. So we'll start, sorry. They want you to start with the area of the whole rectangle. So we'll do that first. Okay. So if I'm going to calculate the length and the width of this rectangle, then I'm going to have to count how many units. So on this edge of the rectangle, I have 1, 2, 3 units on that side of my y-axis. 1, 2, 3, 4 units on that side. So this is a total of 3 plus 4. That's 7 units. Okay. And then the length, I always call the length the longer side. We have 1 unit, 2, 3, 4, 5, 6, 7, 8. Okay. So on one side we have 7, the other side we have 8. So that's where they got these numbers. They're finding the area of that whole rectangle because we're going to use that in our subtraction. So they took 7 units on one side, 8 units on the other. 7 times 8 is 56. It's units times units. So that's how we get units squared. So that is your area of the whole rectangle. Okay. And we're going to use that in a little bit. Okay. Then we're going to look at this, the triangle, number one. Okay. So the base of my triangle number one, I'm going to count right here while I'm here. 1, 2, 3, 4 units on this side for my base. And my height is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I know base times height divided by 2 is my area of my triangle. So for triangle number one, that's where they got these numbers. 1/2. The base was 4. The height, was 8. 8 times 4 good morning, is 32. And 32 divided by 2 is 16. And units times units got units squared. Okay, so 16 units squared is just the area of this piece only. Okay, and we'll show you what to do with that in a minute. Now they numbered this one number 2. Okay, so now I'm going to count the base and height of that. So if I imagined this was the side it was sitting on, my base would be 2 units for number 2, and the height would be the long side, 1, 2, 3, 4, 5, 6, 7. So I would have 7 and 2, and that's what they did for this area. They took the half times the base times the height, 1/2. I counted the base as 2. I counted the height as 7. Remember, they're interchangeable because of the commutative property, so you can multiply numbers in any order. And then 7 times 2 would be 14. Units times units would be units squared. And 14 divided by 2 would give you 7. So the area of that little piece, number 2, okay, is 7 units squared. Finally, I'm not done, because all I've done is I've found the area of the whole rectangle. I found the area of piece number 1. I found the area of piece number 2. And now I'm going to find the area of piece number 3. Okay, so if I counted my base of this triangle, I would see there's 1, 2, 3 units. If I wanted to count the height, then I'd have 1, 2, 3, 4, 5, 6 units. And I would put that into my formula where I have area is 1/2 base times height. So 6 times 3, I would have 18. Units times units is units squared. And then 18 divided by the 2 gives me 9. Okay, so that's where they get 9 units. Now, that's a lot of work, but I'm not done with it. Okay, that's why I said, whew, it's a lot of work. Okay, the question way up here was to determine the area of the polygon. So once we drew it, we had to decide what kind of shape it was, and we figured out it was a triangle. But we realized we couldn't just use the traditional way of counting the base and the height, so we have to figure out a new way. We made a rectangle around it. We found the area of that whole thing. Okay, that's where we got the 56 units. And now what we're going to do is we're going to subtract. If we have this whole thing shaded in as a rectangle and we subtract this piece out and subtract this piece out and subtract this piece out, then we're going to be left with the triangle. And that's what would be left over, and that's what we want to find the area of. So I'm going to take that whole area, 56 units, and I'm going to subtract 16 units from triangle 1, 16 units squared. I'm going to subtract 7 units squared from triangle 2, and I'm going to subtract 9 units squared. And then whatever is left over will be the area of the white part of that shape. So that's what they did here. They took the area of the rectangle, 56 units squared. They subtracted out the area of triangle 1, which we found here. They subtracted out the area of triangle 2, which we found here. And then they subtracted out the area of triangle 3, which they have here. So if you took 56 minus 16, and then minus 7, and then minus 9, you would get 24 units squared. And 24 units squared is the area of just this white triangle. And that is what they asked us to solve. Okay, good morning, good morning. Some people are just jumping on. Okay, so I know that sounds like a lot. Okay, so that's why we're taking it, we took it step by step. It was a lot of parts. You first have to know how to graph all these points on the coordinate plane. That's why we reviewed how to do that. Then the new technique, because last week you learned how to take a base times a height and divide it by 2, or 1/2 base times height to find the area of a triangle. But this lesson is teaching us a new way for when the triangle doesn't exactly match up with the coordinate plane and it's at a weird angle. We have to draw a rectangle around it, a shape that we know and is easy to find the area of. And we have to make sure that that shape lines up with the outer points of the triangle. Then once we find the area of those outside triangles, we can subtract them from the area of the entire shape. And so that's what we did. Okay? And I know that's a lot. Okay? So this was another way that they showed it. The expression, because it said write an expression. So the first term in the expression was 7 times 8. That was your area of your rectangle. And then this was subtracting out the next triangle, and then the next triangle, and then the next triangle. Okay? And so I know it's long, but that's one of the irregular shapes that they wanted us to work on. Okay? Then we have another irregular shape. Good morning. Okay? Now it's still two-dimensional. Okay? It looks similar to shapes that we know how to find the area of. So what they want you to do now is use techniques that you know. Just like we did with the triangles, they want you to use techniques that we already know to find the area of this, which is called a compound or irregular shape. Okay? Now, they may also ask us to find the perimeter, so we're going to be reviewing that. So it says, Jasmine has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area to know how much fencing and dirt to purchase. Determine both the perimeter and area. Okay, so who can tell me how to find the perimeter? Okay, well, let's just start with that question. What is the perimeter of a shape? You could even type it in the comments then if you don't want to jump on. What's the perimeter of a shape? What is the perimeter of a shape? If area is finding the inside part of the shape, right? What is the perimeter? What is finding the perimeter? Good. Okay. The perimeter is the distance on the outside. Okay. So that's what they're wanting you to find for this shape. Okay. So it says we can determine the lengths of each side first and then add them together to get the perimeter. So they're going to find the length of AB. That's the side that connects A and B. BC, CD, DE, EF, and F to A. And that's all the pieces that you would need. So that's what they did here. They counted all those units. From A to B, right? They got 4 units. From B to C, they counted 7, 4. You know, you can count these yourselves in your squares. 1, 2, 3, 4, 5. Then there was 6, 8. And then the long piece was 13. And when you add those all together, okay, when you add them all together, 4 plus 7 plus 4 plus 6 plus 8 plus 13. And you want to make sure you have all the sides. 1, 2, 3, 4, 5, 6. It's a 6-sided shape. So you'd have 6 things you're adding together, right? 1, 2, 3, 4, 5, 6. And you would get 42 units. Good morning. Okay, you'd get 42 units. So that's the perimeter. The area, we don't know the area of finding this kind of shape. So like we said, we're going to use shapes we already know and break it down into those shapes and then find the area that way. So we can decompose it. Remember, we learned this word last week. Decompose, we said last week, was break down. You can decompose your irregular shape into a shape that you know. So this is one example. You could break it into this piece so that you could find the area of this bigger rectangle and then this smaller rectangle, and then we can add them together. Or another way some people might have done it, you could have continued this line all the way down and had one really long rectangle here and then added this other piece. Okay, so, oh, I see you guys are sending me messages. I always read the messages afterwards, so I'll be happy to help anybody I can. I'll look at my Instagram messages after class is over. So we just have a couple more minutes. I want to go through this example, and then I'm going to have you try these problems on your own. And we will probably still be doing this lesson on Wednesday because it takes longer, and Ms. Mixon will also be helping you do a couple of the examples before class when she does her presentation tomorrow. So don't panic that we didn't get this done. We will get it done. Okay, so they broke it into 2 rectangles. This is the one that they're using for their calculations. This is their top rectangle and the bottom. So they found the length was 4 units. Okay, they just counted the units, 1, 2, 3, 4, and then the height, 1, 2, 3, 4, 5, 6, 7, which in a rectangle is the length. So the width times the length. They had 4 units times 7 units and got 28 units squared, because units times units is units squared. Then they took the area of the bottom one. Okay, so this bottom one, 1, 2, 3, 4, 5, 6, 7, 8 is this distance, and 1, 2, 3, 4, 5, 6 is that distance, 6 units. So they multiplied the length of 8 times the width of 6. 8 times 6 is 48. Units times units is units squared. So this piece is 48 units squared. This piece is 28 units squared. So what do you think we're going to do with those 2 to find the area of the whole piece? What operation are we going to do? Type it in the comments. Go ahead and type it in the comments. Oh, people are already jumping off just because it's 10:45. You don't want to jump off till we're done, another minute or so. Just type it in the comments. Good. Good. Great. Yeah, people are typing it in. You're going to add. You're going to take the area you just found of this rectangle, the area you found of this one, and you're going to add them together. Okay? That's what they did here. 28 units squared plus 48 units squared is 76 units squared. Okay? So here's what I want you to do. Oh, by the way, if you have access to Khan Academy, these are the lessons I've already assigned in Khan Academy. If you don't have access to Clever and Khan Academy, you can just type these in on your phone when you have internet access and watch these videos too. Okay, these are all the Khan Academy videos I would assign you in class. So for your turn, okay, and they've given you hints to remember, okay, that when you decompose a figure and you can't leave any of the parts out, when you're drawing a rectangle around the outside of the shape, you have to make sure the vertices of the original shape are touching that perimeter. Okay, so why don't you go ahead and try number 1? This is the other Khan Academy video that I have on there. Okay, 1 and 2, try them on your own. And Ms. Mixon and or myself will go over those with you. Okay, so you're going to do 1 and 2 before our next class. Okay, you're going to try them yourself. Okay, if you have any questions, make sure you DM me. Okay, I'll check my messages after this. This also gets reposted in the YouTubes. You know, it's available for the next 24 hours, but it's also in the YouTube videos that we have for the school if you want to rewatch it. And again, you can still contact me all the ways we've talked about, and we will finish this one up on Wednesday. Okay? All right. Thanks, guys. Have a great day.